Okay, welcome to my second quick video on the EdgeRouter Lite's QoS features. So this video I'm going to cover QoS by IP address, and I'm going to do that under a few different scenarios. So there's a number of reasons you might want to, QoS by IP versus using a waitlist based on ports or protocols. This can range from reserving a certain amount of bandwidth to a certain particular machine on your network, like a server you have. You could potentially limit, Wi-Fi guests, so each guest on your Wi-Fi network can only pull a certain amount of bandwidth. Obviously, you don't want a individual user hogging up all the bandwidth on your network. This can also range all the way down to an uncooperative roommate, somebody who you're sharing a small location with that is, again, abusing the bandwidth, and you want to make it fair for everybody in the household. So if you haven't watched my first video, I do cover logging into the Edge router. Doing that, I recommend that you do watch the video. It will give you a really good explanation of how to log into the router, send commands to it. I'll kind of break down as well what the majority of these commands would do and how they work, so you can make your own rules. I'll post a link to the video somewhere in here, probably right there, right now on the screen. Right there, there it is. Okay, so before we get started with the video, this main topic, I want to talk a bit about how you lay out your networks and the IP scheme. That way you're consistent. So if you manage a number of small networks, I'm sure people run into this, one network is set up one way, another network is set up another way. It's always inconsistent. So I always find it is a good idea to consistently set up your networks, so if you go to a location for a follow-up call, everything is consistent and it's easy to troubleshoot, fast to troubleshoot. So one of the biggest things is laying out an IP scheme, which I'm going to show you what I do personally. And this is just me, so I'm assuming this is a small business, maybe a home potentially, but usually a small business. So they're using a 192.168.x.x and a /24 subnet, or basically 255.255.255.0 subnet, so 256 or 255 IPs on that subnet. So what I like to do, and this is consistent across every network I set up for a small business, that way it's easy to set up the network. So I assign all network hardware, and I do these in 29/29 blocks. There may be 2/29 blocks like you see here, but I do them in /29 blocks. That way it's easy to set up IP-based QoS, which we'll get into in a moment. So I always place network hardware starting at .1 through and inclusive of .15. So what I consider network hardware are things like routers, switches, the gateway for the network, Wi-Fi access points. In most small networks, this is going to suffice. Keep in mind, if you're in a corporate environment, a large enterprise size network, they're probably going to have their own scheme, and it's going to be set for that network. But this is, again, focused on more of a small network, like a small business or a home. So that's generally enough. I always, use .1 as the gateway, .2 is the first switch, etc. The next set of blocks I have are for servers. So again, I reserve, 16 addresses for servers. Actually 15 addresses for servers. That way, you can put things on there. Maybe have a mail server. Maybe the location has, a Windows server or a NAS server. All of the servers are reserved for those IP ranges. So again, easy to find them in the network. Reserve statics. Maybe you want a certain machine on your network to have a static IP. Maybe it's, for example, a point-of-sale machine at that location needs to have a static IP, and I always try to bunch those in a reserved static range. Next would be Dhcp addresses. So these are clients, whether it is the regular computers the office users use, etc. Those are just Dhcp assigned clients. And then obviously you have your broadcast reserve address. So I always try to set up a consistent arrangement of IP addresses for the network. Also, it's generally advisable, if you do have a Wi-Fi network that's public, you'd probably want to have it on a separate LAN, or at least subnet it, but have it on a separate LAN, which is another separate topic. That being said, what I'd recommend next after that would be to think about how you want to assign bandwidth to your machines, kind of write it down on paper, come up with a plan, because that's really going to make all the difference in how you organize your bandwidth. It's important to have that plan laid out. I find it's a lot easier to write the rules when you have something else set up on the side that shows you what exactly you want to do. Alright, so now it's time to get onto the topic. Now keep in mind this is only for inbound traffic. The examples I'm going to show you, what I'm going to cover. You would need to adjust it for outbound traffic, but it should be pretty trivial. So keep in mind this is for outbound traffic only in this instance. In my case, in this demonstration, I have ETH0 configured as the LAN side port. Obviously, you have to make sure you have the port assignment for the interface right when you assign the policy, but I'm using ETH0 as my LAN side port in this demonstration. So what you're going to want to do is you're going to log into your router. You're going to go into configure mode by issuing the configure command. We have, again, the set policy rules. I went over this in the first video. If you haven't watched that, review that. What I'm going to jump into is assigning bandwidth by IPs and in different blocks, right? So say you have a PC. In this case, it'd be in the server range of IPs, right? So say you have, in this case, I'll just leave this here, a certain server. So say it's, actually let's assign this as a dot, let's say it's dot 16, the first server in your network, right? So we'll just change it to 16. So say you want this to be your web server, okay? Or maybe it's a client. In fact, let's just actually assign this to a, in this case we're going to assign to a client address. I take that back, I apologize. We'll assign to a client. So it's a reserved static client. So say it's like the boss's PC, right? And the boss wants to guarantee that they have a certain amount of bandwidth. So what we'll be doing, this will be again be a shaper policy. That's the name of the policy, the class. Again, all this is covered. So this is the name of the policy. I just called it port 80, but you can call any name. The name is irrelevant. It doesn't make a difference. We could even call it, you know, boss PC. We could do that too. So I could do boss PC. Let's call it boss's PC. So anytime the destination address is his address, so the static address we would assign his machine, and the port is 80, so web browsing, we could make sure that, you know, he's guaranteed 10% of the bandwidth no matter what, and it would ceiling out at 20%. Come down. So this is browser traffic. We can also set up more than one rule for the same IP address. So what we would do in that case, we could set up a second rule, again assigned to the IP scope. So in this case, his address is, you know, 192.168.1.32. As a note, it's important to have this /32. You don't define the subnet in an ERL or EdgeRouter Lite with a, you know, the 255 notation. It's all done with this / notation. It's not done as you know, the 4 octets. So in an IP scheme, /32 is one IP address. /31 is going to give you, you know, 2 IP addresses. /30, you know, and so forth down the line. And, you know, /29 gives you 8 IP addresses. So it's important also to note that the EdgeRouter Lite does follow / notation for subnetting. So you can also assign blocks of IPs to a speed. And this is where it gets a little interesting. And here you can see setting up a singular IP. But what if you have a block of IPs that you want to limit to an address? Say you have, you know, a group of employees, and you want to assign those individual employees a certain amount of bandwidth to share amongst a group of employees. Or say you have one person in your home who has, multiple computers, and you want to assign a certain percent of bandwidth to him to all of his computers to share. So this is where we go into a group of PC assignment. So essentially the biggest difference, again, we're calling it PC2 because it's what the rule's name, but doesn't make it, again, this is the rule name. But what you're doing is when you're assigning the address range, you're assigning with a /29, which means all of the IPs in that range would share that bandwidth. So say you had, computer 192.168.1.128 taking up, say you assign this whole group, the bandwidth ceiling is 70%, right? So a quick roughly 40 megabits is what the ceiling is. So say you had two users, .128 and .129, two people that have IPs in that range. Now if one user is downloading something at 25 megabits, this is a hypothetical example, and another user wants to jump on and download something, right? And he starts downloading, it's going to limit the total download speed of anybody of all the downloads, or the bandwidth coming in on that range of IPs to 40 megabits. So the sum of each computer would not exceed 40 megabits as a total. So this allows you to group IPs. So you can assign, in your DHCP range, maybe you want to have, all of your workers' computers in a DHCP range, and maybe the manager's computers, etc., as static IPs. And you can group it up so that the rank and file workers won't potentially be able to crowd out all the bandwidth watching, YouTube, Netflix, Facebook, what have you. Is going to limit how much that whole group of of users shares in the bandwidth range. So that's a really powerful function that you can use to help control bandwidth, by users on your network. I hope everybody found this video helpful. This is just a quick follow-up. I was asked many times to how you do by IP, and I've seen people ask this, so I wanted to cover a quick topic on how to do it. Again, you should be able to zoom in. I'm recording this at 1080p, so you should be able to zoom in and read the text pretty well. Again, please see the first video if you want an in-depth explanation of how these commands work and how they break down. But this just kind of gives you a template that you can look at, and using the information from the previous video, modify to your needs so you can limit bandwidth by IP. Again, thanks for watching. Have a great day.